Hey, Algebra 2 back here with you. We're going to do another video talking about composite functions. Okay, those composite functions is kind of our word for like a function within a function type thing. So looking here at the first one, I just have this scenario. It says if f of x equals x squared plus 4. Okay, so that's one function. I'll make that my teal, green, aqua colored function here, and I'll draw that on the graph. And then g of x equals 1 half x minus 3. And I'll do that one in purple. Okay, so what I'm going to do first here, again, it's asking about the graph, and I have my graph here. So I'm going to graph these two equations, just like how we learned how to do um, before, right? You learned how to graph a line in Algebra 1, um, but then we learned how to graph this quadratic, this parabola, earlier in the year, okay? So this 1 half x minus 3, again, we're thinking y equals mx plus b. Again, if you don't remember this exactly, this can be a good reminder, okay? So that b value tells you where you begin on your y-axis, right? So you begin at -3, and then this m value here tells you where you're moving, right? So you're moving up 1 and right 2 from that b value, right? Up 1, right 2. Yeah, something that's helpful too, you're always going to have access to Desmos as you do these problems. So you can obviously use that as well. See, that's a little bit of a review of graphing a line, okay? Just we got that one there. And then if I was graphing this one, x squared plus 4, again, that's a normal parabola, so hopefully you remember from your parent functions that parabola shape, right? But this plus 4 occurring kind of outside of a group with the x is telling me that I would take that parabola shape and shift it up 4, right? So my vertex would be there. I'd go up 1 and over 1 to both sides, and up 4 and over 2 to both sides. Okay, so there's just two graphs that I have, okay? And I know they're equations, which is awesome, but yeah. And so what we're going to do with these is just kind of analyze these based on these different function notations, okay? So we can look at this first one. It's saying f of 1. And again, a lot of the difficulty with function notation is kind of looking at this and saying, okay, what is that actually saying? What is that telling me? Well, again, remember that anytime you have the number in the parentheses like this, that number is kind of taking the place of the x that was in there before. So really, this is telling you x equals 1. Okay, so normally when we were solving this without the graph, we would just take that 1, substitute it in for x, and then I would get my y answer, right? But with a graph, I don't necessarily have to do that. What I can do is, right, anytime you have a graph, you have an x coordinate and then a y coordinate that goes with that, right? And we have that for these two lines as well, okay? So like in this situation, and when it's asking me f of 1, what it's saying is, okay, I know x is 1, and it's again referring to the f function, so we're just going to focus on this teal colored line up here. So it's saying, okay, when x is 1, and again, it's not very directly asking this, but what it's saying is like, okay, when x is 1, what is the y value in that spot? Okay, so what I would do is I would focus on my parabola here, and I would say, okay, when x is positive 1, which would be right here, so I go up and I say, okay, there's a point at x equals 1 right there. So it's saying, okay, when x is 1, what's the y value? And the y value there would be positive 5. Okay, so really that's all it's saying there. It's saying, okay, when x is 1, what is the y value there? And it would be 5. Okay, so what we could say for this problem, just like the other ones, f of 1 equals 5. Okay, so that's true. Okay, so we got that. We got that for number 1. Okay, similarly for number 2, we look at this. It says g of -4. Okay, so this time I'm going to focus on my straight line here. And it's the same idea. It's asking, okay, when g of -4. So that's saying, okay, when x is -4, what is the y value there? Okay. And so again, I would go on my line, I would go to -4 on the x-axis. I have my point down here, right? So that point is at -4 comma -5, right? So that would be saying, okay, when x is -4, y is -5. So I could say g of -4 equals -5, okay? So that's kind of the basics of it. You might not remember, but you did learn that in Algebra 1, okay? Now is for where the compositions come in, okay? So again, remember what this means. Remember our kind of, when we have these two letters, okay? Again, we work inside out, okay? We work inside out. So again, we focus on the number kind of deepest in the parentheses here. And then we say, okay, where are we putting that, or where are we looking first? we'd be looking at the g function first, and then we're going to take that answer and substitute it into f. Or that's what we would do mathematically. It's going to be a little bit different for the graph. Okay, but either way you think of it, there's kind of two steps to this. And again, we're working inside out. So again, the first thing to notice is 4. Okay, so that's saying, first off, we're going to think, okay, when x equals 4, and I'm sticking with purple here because, again, I'm looking at when x is 4 in my g function, okay, my g of x function, okay? So again, mathematically, what you would do here is substitute in 4 for x and kind of solve and get an answer there, okay? But when I have the graph, okay, when I have the graph, what I'm doing is I'm kind of looking, okay, when x is 4, what's kind of the corresponding value that goes with that, or what's the y value that goes with that? And so I would look first and say, okay, when x is 4, y is -1, okay? So that would kind of be the answer to this. It would be saying, okay, g of -4 equals -1, okay? So that's the answer. But again, remember what we do from here, right? Just like when we did it mathematically. We take that answer, g of 4 would be -1. We take that answer, and then we substitute it in for f. So it's almost saying like, okay, now, okay, for f, if x was -1, we take that answer, we put it into the f equation for x, okay? So if x was -1 in the f equation, what would the y value be there? And that y value is going to be my final answer, okay? When x is -1, so that would be here, what's the y value that goes with that? That would be up there at +5, okay? So that would be the final answer. My second step, kind of my outwardmost step in the process here, would be finding that second value in that f equation. So we'll go through a couple more. I know it's weird. It's a lot to keep track of, but hopefully you'll get the process in a second. Again, the most helpful thing I can say is inside out. Okay, inside out. So we think about that for number 4 as well. Okay, this is kind of opposite where, okay, again, inside out. So the deepest in the parentheses is right here, -1. And again, I'm looking first at my f equation. Okay, so it's saying, okay, in my f equation, x equals -1. That's what I'm thinking, okay? I actually just found that, right? So in my f equation, right, if x was -1, what's the y value that goes with that? Again, that was the same point as the last one, +5. Okay, so that f of -1 equals 5. Okay, so I know that at first. Okay, and then it's not just that though. I take that answer, f of -1 equals 5. So that answer of 5, again, I take that and I'm going to substitute that into my g equation, okay? So again, mathematically, I would say, okay, everywhere I see an x, I'm going to put in a 5 and substitute it, okay? But instead, I can look at the graph too, and I can say, okay, when x is 5 in my g equation, what would the y value be that goes with that, okay? And so let's look here. So my g equation when x is 5, that would be like here, okay? And that looks like it's going to, right, this y value is -1, this y value is 0. So it'd probably be like right in the middle of that. So we could say -0.5. G of f of -1 would be -0.5, okay? Now 5 and 6 look like they're asking something totally different. But again, we talked about this in the other video too, how this is kind of a different notation for a composition, right? This O in the middle of these, okay? And a lot of the time kids confuse that with multiplication, but it's not. Multiplication, you'll see just like a small little closed dot, okay? This one, open circle, looking like a letter O, that's telling you composition. But again, it's kind of the same order, right? It's the same order. So you could write this as f of g of -2, the same way as we'd see the other ones. Again, I prefer this top way of writing it because it helps me to remember that inside out rule. But either way you think of it is fine, okay? So for this first one though, what we're gonna do is we're gonna take, again, inside out, so -2, so that's telling you x is -2, okay? And again, we're gonna take that and we're thinking about it within the g equation, okay? So x is -2, I go to -2 on my x, and so the y value that goes with that would be -4. So I'm not done yet. So I just found g of -2 is -4. That's that answer, okay? But again, then I take that answer of -4 and I substitute it, or in this case, I'm going to look at it on the graph of -4, okay? So for the f equation, when x is -4, right? And this one's a little tricky because I don't have enough space on my graph. I didn't show it. I only showed it over till -2. So in this case, again, when you have the equations given to you, you're kind of, if you can't see it right on the graph, you're kind of forced to do the equation with it and plug it in. Okay. Again, with Desmos kind of solves that too. If you have Desmos, you could zoom out and everything. But so just mathematically, I'll just do that real quick just for review as well. Okay. So again, what we'd be looking for on the blue graph is when x is -4, what's the y value that goes with that? So we know it's going to be a high number. Okay. But I'll just take that and plug it in mathematically instead. So the f equation, instead of x squared plus 4, it's going to be -4 squared plus 4. Okay, so -4 squared would be 16, and then 16 plus 4 would be 20, right? And you might be thinking, oh, doing it mathematically is so much more easy, right? Because it's a lot less to keep track of. And it is. And so what's nice is you kind of have a choice when you're given the equations and the graph. You're kind of given a choice, okay? But we're going to look at one with, because there's problems that they give you too. When they don't give you these equations, they only give you the graphs. And you're then are forced to look at the graph. So that's why it's helpful to know both of them, okay? Now I'm going to go through one more example over on the other side here. So I might have to shift things around because you can't quite see that whole board yet. But that's the concept, okay? So let me move stuff around and we'll go over that one. All right, guys, just doing one more example here with you, like I said, okay? So in this case, but I did not give you the equation, so you don't have like a backup plan of like plugging in to the equations instead of looking on the graph, okay? So we're gonna have to look at the graph here, okay? But I just gave you 4 examples. We'll just walk through them and then we'll be all set, okay? So I put f of x in this dark green, g of x as this straight line, kind of like the last one, okay? Before I do this though, let me just say, even though it doesn't give you the equations, okay, like it did for the last one, what you could do, again, you guys know everything you need to know to write what these equations are. So if I'm going over all this stuff on the graph and you're just like, that's too much to keep track of, which x value goes with which, what you could do is you could just totally say, okay, this equation starts at +4, goes down 1, right 1 each time. So this equation would be y equals -1 plus 4. Okay. And you could get that. That would be the equation of that line. And then this one, again, knowing what you know about transformations, again, it's a parabola with a vertical flip shifted left 4 and up 2. You know how to get that equation. But again, they just don't give them to you off the bat. So if that's easier for you, though, if you think like, okay, finding the equation would be less work for me than doing all this crap, then you could totally do that. Okay. Anyway, I'm just going to tell you one more time how to do this graph, though, and then we'll be all set. Okay, so for this first one, again, we look at f of -7. Again, we see 7. The first number I had up here, you notice it changed. It was actually +3, and it went way off my graph, so I messed up there. But -7, okay, so what this is wondering is, okay, when x is -7, what's the y value that corresponds with that? Okay, so we look at this graph, okay, and again, the f equation is this one, okay, and then, so I'm wondering, okay, when x is -7, so that will be over here. And then, so I go down, okay, the point that that's at, okay, the y value here also ends up being -7, okay. So we'd say f of -7 equals -7, okay. That's the x value, that's the y value that it goes with, okay. The second equation is g of 1, okay, so it's wondering, okay, now looking at my straight line, again, when it gives you the number in parentheses, that's saying x equals 1, and it's wondering what's the y value that goes with that, okay? So when x is +1, right, that would be here, the y value up here, that point, is +3, okay? So we'd say g of 1 equals 3. The x value is 1, the y value is 3. So that's, again, the basics. Now looking at these last 2 composition ones, though, I'm giving it to you in this weird notation because in my experience, when I've seen the questions they ask you guys in Algebra 2 on standardized tests, this is the notation they use more. So I want to make sure you know what it means, okay? So this f of g of 8, right? And so again, you can rewrite it the other way, or you can draw the extra set of parentheses around the second number, right? Because reminding you of the inside out rule. So again, what is that saying? That's saying x is 8 in the g equation, okay? So the g equation is the blue one, right? And so it's wondering, okay, when x is 8, what's the y value of that problem, right? So when x is positive 8, that would be all the way over here. What's the y value? That would be down here, right? And so we would say, okay, when x is 8, y is, that value is negative 4. So that would be the answer to just this part of it, okay? But again, I'm not done there. I'm taking that answer and I'm going to substitute it in to the f equation, okay? Or not the f equation, I'm going to look for it on the f graph, okay? So with that answer of negative 4, okay, I take that answer and I look for that answer on my f equation. And I say, okay, when x is negative 4, what's the y value that goes with that? And that would be this point up here, right? X is negative 4, y would be positive 2. Okay, so that's my y answer to that problem. So the answer to this whole thing, f of g of 8, would be the second, the final one. When you go furthest on the outside, it would be positive 2. So the last one here, same idea. So g of f of negative 4, okay? So again, working inside out. You can draw your extra set of parentheses, right? Because you're just focusing on this first, okay? So we're thinking, okay, f of negative 4, right? So that's actually what we just found, right? F of negative 4. So the f equation, my curve, okay, I'm wondering what is the y value when x is negative 4? And so I look at this, right, same thing, that same top point there at positive 2, okay? So I have that. But then I take that answer and I say, okay, within the g equation then, okay, I take that answer and I would look for it on my g graph. So when x is 2 on my g graph, what's the y value that corresponds with that? And so when x is positive 2, that'd be this point right here, right? And the y value there is also positive 2. So we could say for this one as well, g of f of negative 4 equals positive 2 as well. That doesn't like always happen that it always equals 2. That just, I happen to pick 2 points that were that way. But you can have numbers all over the place. But anyway, that's the concept here. I hope it makes sense, guys. I know it's a weird one, so thanks for following this along. Good job.